Hello everyone, my name is Mario Tiozzo and I'm the Data Analysis and Visualization Librarian here at UMB Libraries. Today we're going to take a look at how to analyze the data in this spreadsheet to calculate measures of variation such as variance, standard deviation, and interquartile range, among others. Once again, we will be using a modified version of the PISA 2022 data for Hong Kong. For the purposes of this video, we will just use the science score data in a column P. Let's copy and paste this in another sheet to focus on this data series. So we go to the top of the data series, click on it, Control-Shift down to get the entire series, Control-C, copy it, go to this tab here, Control-V, paste it. Great. One of the simplest ways to calculate variability in the data is to figure out the borders of the data set. To do this, we need to calculate the smallest and biggest values. We can find these with the min and max formulas, which find the minimum and maximum values in a data set respectively. We do this by going to an empty cell. Let's go here, an F2, and pressing the equal sign, the name of the formula, in this case min, open the parenthesis, click on our first data point, Control-Shift down to get the entire data series, close the parenthesis, press enter. Let's tag this minimum. Do the same thing for max, equals, max, open the parenthesis, first data point, Control-Shift down, close the parenthesis, press enter. Maximum. Great. We can then find the range, or the spread between the minimum and maximum values, by taking the maximum value and subtracting the minimum value. Go to empty cell here, equals maximum minus the minimum, press enter. That is our range. Another way to calculate data variability is through the interquartile range. You'll remember that we already discussed quartiles in an earlier video. The interquartile range is simply the range between the third and the first quartile. To do this, let's calculate those quartiles first by going to an empty cell, pick here, pressing the equal button, the name of the formula, Quartile.INC, press tab to autocomplete. You'll notice that this formula requires two arguments, the array and a quartile. So let's highlight the data for the array requirement. We go to the top of the data series, Control-Shift down to get the entire data series. Then we press the comma to tell Excel that we are moving on to the next argument. And let's set the quartile to 1. Close the parenthesis, press enter. Now let's go back to that cell and lock in the range values by pressing the F4 key. So let's go to this coordinate and press F4 to lock it in, and this coordinate to press F4 to lock it in. Now we can drag this down, and in a second iteration, instead of looking for the first quartile, we'll look for the third quartile. So we'll substitute this 1 for a 3. Great. So this would be Q1, this would be Q3. To calculate the interquartile range, we simply subtract Q1 from Q3. So equals Q3 minus Q1, and that is our IQR. This means that half of the data in this data set are contained around the median with a spread of 125.998 points. Now let's move on to another way to assess data variability, the variance and the standard deviation. I'll first calculate the components of both of these for illustrative purposes, and then we will dive into the Excel formulas. So here we have the formula to calculate a sample variance. We use a sample variance, which is slightly different from the population variance, because we are working with a sample here and not the entire Hong Kong student population for this age group. If we look at the formula, in order to find the sample variance, we need to calculate the distance from the mean of each data point, square those results, then add them up. We then divide that number by the number of observations minus 1. So let's take this step by step. First, we need to calculate the mean of a sample and a number of observations minus 1. So let's do that here. Let's write mean and count minus 1. We know how to calculate the mean. That's the average formula, equals average, open parenthesis, first data point, Control-Shift down, close the parenthesis, enter. And a number of observations is the count formula, equals count, open the parenthesis, first data point, Control-Shift down, close the parenthesis. But before we press enter, we go minus 1, because that's what the formula requires. Press enter. Great. Now let's calculate the distance from the mean of each data point. Let's go to column B here, B2. We take the first data point in A, so equals this data point, and we minus out the mean. So minus the mean, which we've just calculated. Let's not forget to lock in the mean value using the F4 key so that we can drag the formula down and the cell holding the mean value will stay in place. Press enter, Double click on the bottom right corner. Great. Let's test it out here. The formula is doing what it's supposed to. Terrific. Let's tag this mean diff. Now we need to square the values in mean diff. So let's go to the next column. Go to C2 equals our first instance of mean diff. We want to square this, so we'll press Shift 6 to get the caret sign. This creates an exponent, and since we want to square it, the exponent will be 2. Press 2 and press Enter. Again, we can double click on the bottom right corner to drag out the formula. Perfect. So this would be mean diff squared. Now we have to add up all the mean diff squared to get a total. So we can go to an empty cell here and just simply sum the values of mean diff squared. Control Shift down, close a parenthesis, press Enter. Put this as numerator. I'll adjust the column width by double clicking on the border. Great. Now we have all the components to calculate our sample variance. Put variance here. We have our numerator right here, which is the sum of the mean diff squared. We divide that by the number of observations minus 1, which we've calculated here. And that is our variance. One of the problems with the variance is that because we are squaring it, the variance units are also squared. So if the units here are points, the variance would be 8,293.484074 points squared, which isn't super intuitive. To get around that, we often take the square root of the variance to get the standard deviation. There's a formula in Excel for the square root. It's SQRT. So let's use that in an empty cell. Equals SQRT. Open the parenthesis. We include the cell that holds the variance value. Close the parenthesis. Press Enter. Let's tag this. Standard deviation. So instead of saying that the spread from the mean is 8,293.484074 points squared, we can say that the spread from the mean is 91.068578 points, which is a lot more intuitive and makes it easier to compare to our other metrics. Okay, so you may not always want to calculate the variance or the standard deviation this way. With Excel, there's an easier way to do this using formulas. For the sample variance, we do this by going to an empty cell, pressing equal, typing in the formula, in this case, var. You can see that we have var.p for the population and var.s for sample. So we want to use var.s because we are using a sample. Open the parenthesis, go back to our original data. First data point, Control Shift down, close the parenthesis, press Enter. If I make this a little bit bigger, you can see we have the same result. We do the same thing for standard deviation, equals STDEV. We have STDEV.p for population or .s for sample. Again, we'll use .s for sample. Click on the first data point in our data series, Control Shift down, close the parenthesis, press Enter. And again, you can see that we have the exact same number, but this time Excel's done all the calculations for us. Now that we've done it with the raw data, let's try to do these calculations using a frequency table. Let's go back to the frequency table we built earlier using the student grade levels. Let's start with identifying the minimum and maximum values. So that part's pretty straightforward. The table has them laid out for us. We'll put in minimum here, maximum. And we can see that the minimum is 7 and the maximum is 11. Let's test this with our data set using the min-max formulas. Equals min, open parenthesis, first data point in our data set, Control Shift down, close the parenthesis, press Enter. 7, great. Equals max, open parenthesis, first value, Control Shift down, close parenthesis, 11. Great. Now we can calculate the range, which is just the maximum minus the minimum, 4, and of course it'll be the same thing on this side as well. Terrific. Now let's calculate the interquartile range. As you remember, we first need to calculate the first and the third quartile to do this. Put Q1 here and Q3 here. The formula to find the position of the number in the first quartile is n+1 divided by 4. So to find the position of the third quartile, it should be 3 times that. So let's try to find the position to begin with. n+1, n is the frequency, open the parenthesis, n plus 1, close the parenthesis, divided by 4. And we'll say 3 times this number would be the position of the third quartile number. So we now know that the first quartile number is at the 1477th position in a sorted data set. But how can we figure out where this is with our frequency table? To do so, let's calculate the cumulative frequency, much like we did the cumulative percentage in an earlier video. Go equals the first number in the frequency column, then equals that number again, so H2 plus the second number in the frequency column. We can drag this down now, and now we have the cumulative frequency, cumulative F. Now we can see that 1477 would fall in a 9 segment, and that 4431 would fall in a 10 segment. So let's put that here, 9 and 10. And let's test it with our data set. Equals Quartile.INC, first data point, Control-Shift down. Remember, we have 2 arguments here, the array and the quartile. So we put the comma, and we want the first quartile in this instance. Close the parenthesis. 9, great. Let's lock in our range values by pressing F4, drag this down, and in a second iteration here, instead of the first quartile, we'll be looking for the third quartile. 10, great, that works out. So now we can calculate interquartile range by taking Q3 minus Q1. So our interquartile range is 1 grade level, and it will be the same thing on this column, of course. Finally, we want to calculate the variance and standard deviation of this frequency table. Here we have the formula to calculate a sample variance of a frequency table. The formula for this is similar to the one for the raw data, but you can see that we multiply the results by the frequency in the numerator, and we use the sum of the frequency instead of the number of observations in the denominator. Let's start by calculating the mean difference. Let's go to our frequency table in an empty column, and we go to C2, and then we minus out the mean. We'll press F4 here to lock in the mean value, press enter. Now we can go back to this cell and double click on the bottom right corner, and we can see the formula is doing exactly what we want it to do. The mean is locked in. Let's call this mean diff. Now we need to square those results. So equals this number, caret sign, 2 equals, and we will double click on that as well. So this is mean diff squared. And now we need to multiply the mean diff squared by the frequency. So we'll take this number now, and we need to multiply it by the frequency, which is right here in column D. Double click again here to drag down that formula. Double check here. Yeah, it's doing what it's supposed to be doing. So this is mean diff squared times F. If we want to be slightly more sophisticated with Excel, we could nest these 3 last steps into one. So we would do this by going equals, open the parenthesis, C2 minus the mean, which we would lock in by pressing F4, caret 2 to raise everything to the second exponent, and then we will multiply that by the frequency. Press enter, and if we drag this down, we would note that column K and column L have the exact same numbers. So the results are the same, but it keeps your spreadsheet a little cleaner. It's up to you to figure out which one you prefer. Finally, we need to take the total of MDS times F. So equals sum. Perfect. This will be our numerator. Okay, we have all the elements we need to calculate the variance. Put variance here equals the sum of the squared mean difference times the frequency, which is right here. We divide that by the sum of the frequency minus 1. So the sum of the frequency is in cell D7. Minus 1. So we'll open the parenthesis. There's our sum of the frequency, minus 1, close a parenthesis, 0.3554. So if the units in this data series were grade level, then it would be 0.3554 grade level squared, which is a little difficult to interpret. Let's check this out versus our raw data. Equals VAR.S, open the parenthesis, first data point, all the way down with Control-Shift down, close the parenthesis, exact number. Perfect. To get the standard deviation, we simply take the square root of the variance. So we'll go here, press equals SQRT, open their parenthesis, square root of the variance, which is in E20, close our parenthesis. So we get 0.5961. If the units for this data series were grade level, then it would be 0.5961 grade level. So that means that the spread of one standard deviation is plus or minus 0.5961 around the mean. Said another way, if we had the mean here, The spread of one standard deviation would be the mean minus the standard deviation and the mean plus the standard deviation. So one standard deviation away from the mean would be 9.017 to 10.209 grade level. So let's tag that and let's verify it against our data set. STDEV.S, top of our data series, Control Shift down, close the parenthesis, the exact same number. Terrific. Okay, that should be good for now. We've learned different ways to calculate measures of variation, whether it be with raw data or with a frequency table. I hope that this was helpful. Thanks for watching, and I'll see you in the next video. Bye for now.